going to discuss the concept of law of division of exponents. If we have two exponents with the same base and we are dividing them, for example, if I have a raised to power m is divided by a raised to power n, or we can say a raised to power m upon a raised to power n. That means they have the same base a and they have different powers, exponents m or n. Then for this it is equal to a raised to power m minus n. So first let us verify this relationship. Let us suppose we are supposed to divide 2 raised to power 3 divided by 2 raised to power 2. According to the law, it will become 2 raised to power 3 minus 2. That means 2 raised to power 2, or we can say 2. And if I try to simplify using the different methods of expansion, I will say 2 raised to power 3 upon 2 raised to power 2 is equal to 2 into 2 into 2. Because 2 raised to power 3 means I am multiplying 2 3 times. Similarly, 2 raised to power 2 means I am multiplying 2 times. That means 2 into 2. Now I will try to simplify the fraction. This 2 will cancel out with this 2. Let us suppose this cancels out with this, so we will get 2. Hence this value is equal to the same value. That means the left hand side is equal to the right hand side. We can say the law has been justified. That means if 2 raised to power 3 upon 2 raised to power 2 is equal to 2 raised to power 3 minus 2. Here it was 2 and again 2. That means left hand side was equal to the right hand side. So the law has been justified. So we can say this law of division for the exponent states that if we have two exponential terms with the same base, then we'll have the common base and we'll subtract the powers. That means a divided by a raised to power m upon a raised to power n will be equal to a raised to power m minus n. Now let us take different examples to use the law of division of exponents. For example, I have to solve 7 by 9 divided by 7 by 3. As they have the common base 7, so it will be equal to 7, 9 minus 3, and I will get 7 raised to power 6. Similarly, in the second example, I have 8 raised to power 5 divided by 8 raised to power 7. Again, they have the same base 8, so it will be 5 minus 7. That means 8 raised to power minus 2. But in the third example, I have 8 raised to power 5 and 2 raised to power 4. As now we see that the bases are not the same, we will try to make the bases same. So 8 can be represented as 2 raised to power 3 and whole raised to power 5, then 2 raised to power 4. That means a raised to power 3 is raised to power 5 is upon 2 raised to power 4. Or we can say, when we will open the bracket, 3 into 5, we will multiply 3 into 5, we will get 15 upon 2 raised to power 4. So this is equal to 2 raised to power 15 minus 4. Because now the bases are same, that is 2. So we will subtract the power. So we get 15 minus 4, it is equal to 2 raised to power 11. So let us sum up the concept. Whenever we have the exponential terms in which the bases are same and we are performing division, we will have the same base 9 and we will subtract the powers. That means 9 minus 3 will get 6. So we got 7 by 6. In the second example, it was 8 raised to power 5 divided by 8 raised to power 7. Again we had the same basis 8. So we performed division by subtracting the powers. That means 8 minus 5. So I got 8 raised to power minus 2. But in the third case, we didn't have the bases as the same. So we first tried to make the bases same. For this, we'll express 8 as 2 raised to power 3. Because 8 means 2 into 2 into 2 and 2 raised to power 3, which is further raised to power 5. So we'll simplify it as, when we'll open this bracket, we'll multiply the powers. 3 into 5 will be 50. And in the denominator, we'll have 2 raised to power 4. So it was 2 raised to power 15 upon 2 raised to power 4. Now the bases were same, so we applied the law. So we got 2 raised to power 15 minus 4, that is 2 raised to power 11. This is how we perform division in the case of exponents when the bases are same and the powers are different.